So, guys, again, welcome and thank you so much for being here. And let's go ahead and start our webinar. We have tested the audio and video. Just shout in the chat if you have problems technically so that I could guide you how to troubleshoot it. And of course, let's now make sure that there are no notifications in our webinar. Please go to the settings icon here, right at your lower right hand corner. And if you click that, you will see the notification settings. Make sure that all the boxes in here are not checked or blank to make sure that no notifications are popping up as we go along the webinar. All right. And if you have questions about the recording of this webinar and also the slides, the copy of the slides, we will be sending that to you after this whole event, which is the virtual open week, which will end on Thursday. So rest assured that you'll receive those. And I will now, and this is about the lectures, insights, electrical engineering, and renewable energy at EIT webinar. And this is going to be handled by Dr. Hussein now. And you may start now, Dr. Hussein. Thank you.
Thank you very much, Lisa. Thank you very much, everyone, for the wait. And again, I apologize for the late. Dr. AK also, who were supposed to join today, he had also a family issue just now. They informed him about something has happened to his father, and he could not join. So I will be taking over the whole seminar for today. And yes, we mainly are going to talk about electrical engineering. So I'm going to give you some insights about the electrical engineering originally, and what are the different aspects that we study, we do the research, etc. in electrical engineering. And afterwards, we will be talking about what actually EIT offers in electrical engineering. And I'm going to go through some of the courses and the professional certificates that we offer. And hopefully by that, you can find a way to join EIT, and we could have you on board in EIT. So yeah, this is Dr. AK. As I mentioned, he is also a lecturer and course coordinator in EIT, but he could not join today, unfortunately. I myself, Hossein, yeah, I mainly work in academic and different Australian and overseas universities. My PhD is in electrical engineering. I got it from NTU, Nanyang Technological University in Singapore. And my research and work are mainly focused on renewable systems and their integration with the power system. And I'm going to talk about them a bit later as parts of the aspects of the renewable system. So let us start with the first part of the presentation today, which I'm going to talk mainly about electrical engineering and renewable energy itself, so that you get familiar with the area and the aspects that are used in electrical engineering. So of course, nowadays all of our life is dependent on electricity, from every single equipment that we use in the house, in the on the road, etc. So everything is now by electricity. Uh, of course, some of the reasons that you guys may know, that why don't we go with other sources of electricity, sources of energy instead of electricity, and everything is nowadays electric. One of the main reason is that electrical power is easy to transfer. You just can transfer it through wire, but not like gas. If you know, gas, for example, has a lot of other complexities, or other types of the energy, right? So this is one of the main reasons that has become the main source of electricity energy for our consumables. And it can have it can start from small items that we have, like the mobile phones, or it can go up to the big items that we know we use for our commutations in the cities or between the cities, like this um, uh, electrical trains and so on. So, and it can go to electric motors and so on that we use nowadays in every aspect of our life. So once we talk about the electrical engineering, we are covering all different aspects, all of these different subfields. I'm gonna talk about them a bit more detail one by one. So first of all, let's say we will talk about the sources of the electricity. Sources of the electricity, whether they are the conventional power plants, steam-based power plants, coal-based power plants, and so on, or it nowadays what is more and more frequently used, renewable systems, starting from photovoltaic panels that is installed in most of our houses nowadays. And mm, uh, so one part, one subfield in the electrical engineering is the sources or the methods that we transfer or we extract the power from these main sources, being renewable systems or the non-renewable system, which what we call as conventional power systems. The other aspect would be the transmission of the electricity from the sources to the loads, right? So how do we what are the challenges that we have in the transmitting the electricity? Why, for example, we go for high voltage transmission lines that you could see between the cities, right? Why do we go for three-phase system? Why most of our high power systems or loads are three-phase system? Why don't we, for example, go for, why didn't we use four phase in our original design of the electrical system, right? So, so it the second subfield I'm trying to say that is going to the transmission of the electricity, and what are the aspects that we need to study, we need to have a think, we need to research on transmitting the electricity from the source to the load. The third phase would be, of course, the loads that we have. For example, nowadays in our appliances that we use, we have a lot of chargers, right? So they have different configurations. For example, a charger that you use for your laptop or your mobile, going to a uh, the supply that you have, for example, in washing machine. So each of these systems are having their own circuit configuration, having their own system in them, right? So here it becomes important. What are the different configurations? How do we uh, convert convert the electricity back, energy that we have from the electricity back to, for example, heat in a heater, or to a mechanical power in a motor, right? So this is another subfield that is being studied in electrical engineering, right? And of course, how do we design this system? How do we build this system? So these three subfields, they are related to the electric energy from the source to the consumption or to the load. Then, in addition to these subfields, of course, we need to study the communications that are required between these systems, right? And then that could go up to, for example, the radio frequency communications and other types of communication that we use, for example, for to transfer the data. So that would be another part of another subfield in electrical engineering that we normally study and we need to know, we need to be aware of. The other part which is mainly focused on the control, right? So for example, as a simple example, if I would like to tell you, for example, in the fridge that you have in your house, uh, you know that sometimes itself it turns on the motor and it makes the fridge cold, right? So, but the question is, this system is automatic. This system has some controller in it, right? What type of controller, what type of controllers do we use, right? Or I give you another example. I'm trying to give some all practical examples. Let's say you have an electric car, right? So in your electric car, for example, you set the speed to a fixed speed, and no matter whether you are going uphill or downhill, the speed of the vehicle stays constant, right? Or almost constant, right? So there is a controller inside this system so that it looks at the speed, it looks at the, for example, the amount of energy that is used in the motor, so that it controls the speed of the motor. Another subfield that we need to look at, and we look normally in the electrical engineering, is the energy storage system. Now that we have so much dependence on the electricity, and we need to know how do we store this electricity. For example, if it was a chemical energy like a fuel, we know, everybody knows, okay, so we have the fuel, we just have a tank, and we have so on, right? But now that we have electricity, how do we store it? It comes to different technologies that we use in battery systems. It comes to the different ways that we store. For example, nowadays we have it's becoming very common to use hydrogen-based energy storage system, like what we use as fuel cell and then electrolyzer and so on. So this is another subfield that we need to look after, and we study in electrical engineering. So the point is, in overall, since nowadays every single component of our life, in our house, in our car, in the train, in the airplane, everything that we see, it is based on electrical energy, right? Based on electricity systems. And even we have a trend to go towards more and more electrical based systems, like the trends that we have from the combustion engine cars to the electric cars, right? So there is a trend, there is everything based on electricity, and there is a trend going towards more and more electric based systems, right? So, and this is where the electrical engineering stands. It studies, it analyzes, and it designs every single part of our life, almost, I can say. You can see nowadays, especially with this, in these modern houses, we have even all the control. We are controlling the doors, we are controlling everything with electricity, right? With controller. So how do we do this design these systems, how do we make these systems, and so on. So these are all different things that we study, we analyze, and we look at in electrical engineering. Yeah, so as I mentioned, we talk about we study the power plants and new technologies for harnessing the and distributing the power between the loads, which has its own challenges. It's not that we say, okay, so it's simply there is a generator, and it has its own challenges with it. It goes about the telecommunication platforms that we have between these systems. Yeah, it goes about power and lighting of the houses and electro, etc. It studies also electronic components that we use in computers and uh, other work. So I really like this census. As an electrical engineer, you will help power the world, because every single point of this world nowadays is based on electricity. Every single component that now you see, you look after, you look beside your everything that you have in your room, or wherever you are standing now. If you look around, everything is electricity. So as an electrical engineer, you are going to help to power the world. You will work with other engineers to make all the things modern life, that all the things that the modern life requires. It makes them faster, it makes them smaller, and it makes them better for the environment. And this is the reason that we have a big motivation towards going more and more electric based systems, from starting from car, from power plants, from renewable systems, and so on. So if you are interested, this is a good field. This is a this is a the trend that we are going everywhere, every single point of our life. So if I go back, if I say a few more words here. So as I mentioned, the main reason that we are going is that going towards more and more electric based components and appliances gives us more flexibility because we can control the electric power in a more flexible way than any other type of power. It normally makes the things smaller. That's what we are looking for. For example, we are making to have systems that are in a smaller size, right? So this is what we look for, and this is what we can get through electrical system. This may not be easily achieved in a mechanical system or any other types of energy systems. So uh, on that case, so we could see that the technology that we have and is based on the electrical power has been grown, especially in the last decade, has been such a big jump in the technology starting. I mean, a simple thing that some of you may still remember, uh, maybe even just 10 years ago or 15 years ago, we were using this floppy disk for computers and they were having just 200 kilobyte and everybody was happy that it has such a big memory in it, right? But nowadays, now you can see we have a small pen drive which is having 10 terabyte, right? So this is a big jump in the technology. And again, going back to the electrical engineering, this is what you study and this is what you analyze in the electrical engineering field. So on this side, we are looking for battery technologies, as I mentioned. One of the reasons is now that everything is based on electricity, like your phone. What type of battery you use in your phone? What type of battery you need to use in a toy for your kid, right? What type of battery you use in your laptop, right? There are different technologies. You do not use the same technology that you use in your mobile phone in an electric car. You do not use the same thing in a train, right? So each of them are having a different battery technologies, and this is what you will learn. You will study that. You will learn about the autonomous vehicle technology. This is another thing that I did not really mention so far. I mean, we talk about the electric cars, but we are also studying the autonomous vehicles, driverless systems. How do we make a system so smart that it can, uh, for example, as a car, it can drive without driver, right? So we are looking for, in as part of the electrical engineering field, we are looking for translating the way that our brains, the human brain works, to algorithms that the we can implement in physical systems, right? And this is, I mean, the thing that you in the last 1 year or 2 years you could see about a lot of talks about discussions about the artificial intelligence and so on, and every day everyone nowadays uses ChatGPT and other kinds of things. So this is translating what our brain does, a human brain does, to a real technology, to an algorithm that does a similar way, right? This is another thing we can use, and of course it can be used in an autonomous vehicle technology. Another thing that we look for, of course, once we have so many electric vehicles, we need to have charging stations. And then on the other side, we need to think that, okay, so I have a conventional, let's say, combustion based car that I can fill the fuel in 2 minutes, right? Or in 1 minute or 2 minutes. So if I want to have an electric car, my ideal case is that I can charge it so fast, let's say in 2 minutes, in 3 minutes, right? But nowadays, still the chargers that we have or the technology that we have still doesn't do, right? For example, the electric cars, they may need 20 minutes to 30 minutes to charge based on the technology or based on the power that they need. So it comes to the charging stations. How do we develop charging stations and technology so that they can charge electric vehicles in a short period of time, so that you as a customer, you don't need to wait in a charging station for a long time. And yeah, and I think that I mentioned, I really want to emphasize here is about the discussions that we have about renewable systems. For several reasons like greenhouse effect, lack of conventional sources, being expensive, and so on, and going towards a sustainable energy system, we all of us have a tendency towards going renewable systems, like wind power system, like PV system, photovoltaic systems. That is, for example, in Australia, if you look, uh, almost 70% of households are having 5 kilowatt to 10 kilowatt solar system. So, and there are days, there are hours of day that all the loads are supplied us just by these PV systems, and we don't use any conventional, we don't need any conventional uh, generation. Or, for example, in wind system, if you look at a country like Denmark, Denmark not only supplies all of its own load by wind power, and those wind powers are offshore inside the sea. Uh, it also supplies a lot of electricity to Europe, to other countries in Europe like Germany, etc., uh, that are generated based on wind power, right? So, because of all different reasons that we are going towards the renewable systems. But having renewable system based generation, it has a lot of challenges, and this is one of the most important topics that, or challenges that nowadays we have in power systems. Originally, if you look, if I give you just 2 3 sentences just as an overview to understand, originally all this power system that we have, it is designed based on a conventional system, which the power is generated in a big power plant. It is going to a transmission line, and it comes to us as a customer, or the load, right? On the other side, now that I mentioned, for example, in Australia, we have 80% of, there are time of the day that 100% of the load is supplied by the photovoltaic systems that are installed in houses. The scenario is very different, right, from the conventional system that we have. So this high penetration of renewable systems, of course, it adds a lot of advantages to the system, like sustainability, etc. But it brings a lot of challenges to a power system, right? Because the original power system was designed based on a different theory, that okay, the power is going to be generated in a big station, is going to be transmitted, we have big generators and so on. But now that everything is based on renewable, based on inverters, we don't have any more generators, we are having a lot of issues, right? And this is, I tell you, this is one of the most important and demanding aspects that is being studied, and still there are research going on solving the challenges in in the power systems with high penetration of uh, high penetration of renewable systems. So yeah, so again, coming back to electrical engineering field, you are going to study that, you are going to analyze that, you're going to understand that. I'm going to skip this slide. Of course, I'm sure everybody is familiar with the term renewable energy. In one sentence, if I want to make it very clear, is on the definition, or the difference that we define between a renewable energy and a conventional energy system, is that a renewable energy, any source that we call as renewable energy, it can be, if we use it like a PV power or wind power, it could be generated in a short, regenerated in a short period of time. For example, if we use a PV power, the energy is coming from sun. So we are not just finishing the sun energy, right? So that is already coming towards the ground, right, or towards the earth. So, but on the other side, for example, if once we use oil or coal, right, the oil or the coal has taken years and decades to be generated, right? Once we are using now, it is not going to be replaced soon. So that's why the conventional or the non-renewable energy systems are getting finished, and they are not sustainable anymore because they cannot be regenerated in a short period of time. But on the other side, as I mentioned as an example, solar power, you do not finish it because you don't change it even, because the same amount of energy, either you have the PV systems or you don't, is gonna be coming towards the earth. Or the same thing, the same story about the wind energy. Or we have a lot of technology talking about the wave energy from the sea, right? Or hydropower and so on. So this is the main difference. If you're not aware, this is the main difference that we have between what do we call as renewable energy and non-renewable energy system. Of course, now we are talking about the current trend, and in future, the system will be more based on the electrical system will be more based on renewable systems. It will be more based on wireless charging. I need to touch base on this as well. So another subfield that we are studying in electrical engineering is the wireless chargers. So see, nowadays, for example, once we talk about electric cars, or even like vacuum cleaner that we use in the house, if it is it for example, in a vacuum cleaner, it normally needs to be connected to the electricity supply, right? But some of us, including me, are so lazy. We don't want to always go get connect the wire to the socket and so on. So there is a trend towards going wireless systems. This has also talking about the wireless chargers for mobiles, right? So now the question comes: how do we transfer the energy? How do we transfer the electrical energy in a wireless mode, right? It of course increases the convenience to the human. It increases the safety of the system. For example, electric car, for example, in you need to go and if you need to go and connect the socket to the high voltage and high power, there is a risk. But if it is getting charged just in a wireless manner, so that risk is reduced, right? So in future, we will have more and more wireless charging stations or charging systems, I call it. The amount of installed photovoltaic system would be increasing. One of the main reasons is the the cost of photovoltaic panels are decreasing nowadays because of the uh, advancements that we have in the technology for photovoltaic systems. The efficiency of the systems are going to be increased. That's one thing that I did not really talk too much about it. The systems are getting to go towards more robots and uncontrolled unmanned systems like manufacturing and so on. I touched base about the artificial intelligence that we have, and going a bit more details. Also, we will be having more microelectronic systems and more nanotechnology based appliances. So again, coming back to my first sentence, electrical electrical engineering is covering everything that we have around us, right? And it covers, as an electrical engineer, you will be familiar and you will be having knowledge on about all of these different aspects of electrical engineering, like data and machine learning, like about the renewable systems, about the sustainability of the systems, about the conventional and transmission lines and all other things that are related to electrical engineering. I would like to stop here for 1 minute to see if there is a question from anyone, and then I will continue about what EIT offers in electrical engineering. Is there any question from anyone that you would like to raise, please? Yeah, thank you very much, Huma. If I'm not, yeah, so I'm gonna talk about this too. So um, the twin technology, uh, if I'm not mistaken from your words, is that we try to simulate the systems and we try to make an emulation of a real system compared to it. We use this, for example, if we want to model a big power system, and let's say if we have a big uh, photovoltaic system or photovoltaic inverter that is going to be connected to a big power system. Before we connect that to the real system, what we could do, we could connect to a digital twin of that system. And what it does, it is simply a simulation system with some physical interfaces. It's just not it is not only a simulation like what you do in your in your laptop, because in your laptop you just have modeling of a system. You just have a model of a system. You do not have any you do not have any sorry, you do not have any physical system in your laptop, right, that you can connect and interface it with some other. But digital twins are used with to model a big system and study and analyze a big system. And once we add the what we call as a new system, new inverter or new generator and or new load to that system, it could be analyzed. So going to the next question, transformer testing courses. I don't think we have. I mean, in the Bachelor of Engineering and Master of Electrical Engineering, we have courses that are studying or talking about transformers. But I don't. We do not have at the moment. We do not offer a course or professional certificate about testing of transformer. But I think we have received several requests like yourself, and this is something that we could think of developing for the future. Yeah. So Patrick, thank you very much. How wireless is wireless charging if we still need magnetic field transmission of the energy? So the difference is if you are charging a car in a with a wire, of course, you know you need to connect the wire and so on. But in a wireless, there is no electrical contact between your car and the station. Of course, the charging is going through the wireless is through a magnetic field. That's the only way we can transfer the energy between the two coils, right? So it this the same that's the same concept that is happening in a transformer, right? So uh, using a magnetic field or a magnetic energy, we are transferring the electricity between the two windings, which is one winding in the station and the other one on the car. The same concept is about wireless charging for your mobile. Also, that's the same thing. So uh, the next question: solar, wind, geothermal. Which one is the best in future? Depending on the location, of course. You cannot. I don't think there is a general answer for the whole world that I can tell. Based on the condition, based on the location, each of these things could be used. For example, in Australia, we do not have much wind power plants because we do not have much wind, right? But we have a lot of solar. We have a lot of sunny days. So here, we have a lot of solar systems are increased. On the other side, for example, gave the example of a country like Denmark. They don't have a lot of sunny days. On the other side, they have a lot of wind, so they use wind. So I don't think there is a general answer to this question as a best technology for the future. It depends on the location, and after all, it depends on the economical aspects of the system. You need to, once you are installing the system, you are spending too much money on that. You need to see the economical aspects of that. So please elaborate more on the micro technology and nanotechnology. On the micro and nanotechnology, we are using semiconductors, and these semiconductors are being used in the electrical equipments. Right. So that's that's the thing that we also study in electrical engineering systems. What is restructured power systems? Yeah, I touched base a little about that. I mentioned conventionally the power systems are designed based on the theory and based on the idea that the, the electric power has been generated in a big power plant, and then it is transferred to loads. So the power is always radially distributed from the big transmission lines from the big generation systems towards loads. But nowadays, the renewable systems are installed. So, for example, in your house, you have a PV system, which is a renewable system or renewable generator, you can call it. And at the same place, you have the loads for your house, like heater and washing machine and so on. So this change from centrally generated power systems to distributed generated base power system needs a restructuring of the system. And as I mentioned, this is one of the main challenges that we have in the power system. The ideally the theory should be different. Now we need to think that uh, now that we have this new system and is based on renewable systems, how do we restructure the power system? Do we still need this big and long transmission line? Are we going to are we going to have just a small microgrids and every city just supplies its own uh, loads, right? And so on. So this is a field. This is a field of research that we are uh, in the electrical engineering. So you mentioned battery, more explanation on that, sir. Yeah, I mean, I mentioned the different battery technology that we have. So we are looking for battery systems that are more reliable. For example, uh, different types of battery systems, like we have the lead acid battery systems that, for if you see in your conventional car, you have one lead acid battery system, which is 12 volts, right? It's in almost in all the cars that we have in. So this is lead acid based battery system. It is very safe. It is, however, it does not have high energy density or power density. But in your conventional car, you don't need this big because you just use this battery to start your car. On the other side, in an electric car, which all the main source is coming from the main source of energy is coming from the batteries. You cannot use a lead acid battery because it's gonna be very heavy. It needs a lot of space and so on. So uh, you start thinking of a new technology of the battery. For example, lithium-ion battery systems, right? They are having higher energy density. They are having, let's say, higher power density. But on the other side, they have safety issues that you need to think of, right? So these are different aspects that we need to study and we need to understand in the battery system. So if it is okay, I'm gonna continue with the presentation, but then at the end, I come back to the rest of the questions, if that is fine. Uh, I will come back to all the questions, and Lisa, you will help me with the question that I missed. So as EIT, we offer different courses and different courses in electrical engineering. Starting with graduate certificates. That the graduate certificates, they are a 3 month courses we do for individuals, or we do for even groups from the companies, etc. So they are very specific on different topics. Like for example, we have a graduate certificate in renewable energy technologies, which is mainly, as the name is clear, focusing on the renewable energy systems, right? And they are more towards the practical side of the subjects. We offer undergraduate certificates as well, a similar one like to the graduate one. We offer the Bachelor of Science. We offer the Bachelor of Electrical Engineering. Of course, we are talking here. Well, yeah, in general, we offer the Bachelor of Science degrees. So in electrical engineering, also we have which it covers. I think it touch bases all of different aspects that I tried to mention in my first part of the presentation. We have the Master of Engineering, again, electrical systems, which is a 2 year master. The Of course, it after passing the requirements to entry requirements, you can of course enroll. The courses that we have, for example, in Master of Electrical Engineering, you can see there we are talking, each course is targeting very specific parts of the power system. For example, we talk about the power generation, we talk about the transmission and distribution systems, going towards the power conversion, which is mainly about power electronics. Here you can see another course, renewable energy systems, that we mainly focus on different types of renewable. We discuss each of the uh, renewable energy systems, like uh, wind, geothermal, fuel cell, and so on. And then we go also towards the more advanced topics like smart grids, which as part of the restructured power systems, which you have mentioned. We also talk about we have a course about power quality and mitigation of power quality. And at the end of the master, you need to pass, or you need to have a project thesis, which is a research based thesis, and in that you are going to focus on some specific research area and do the project on that. In addition to them, we have the Doctor of Engineering, which has some differences to what we call as PhD. You could see the differences, of course, from the website. We have provided a clear definition of what is called Doctor of Engineering, but in simple words, it's the difference is, as a doctor of engineering, you are going to focus more on practical issues and solve the practical issues in the industry. So your project that you are going to have in doctor of engineering, which is 3 years, if I'm not wrong, so 3 or 4 years, your research project will focus on an industry based practical problem, and then you will focus on solving that issue. So coming back, I mean, on the graduate certificate and undergraduate professional certificate courses that we have, I think there is another next slide. Yep. So as I mentioned, the professional certificates are targeting very specific areas. For example, we have a professional certificate of competency in arc flash, which is really related to the battery system, and arc flash is discussed and designed for in battery system. We have, for example, for big data analysis in and its application in electrical grids. We have professional certificate in circuit breakers. This is very practical one for a lot of electrical engineers, and so on. And at the same time, we have the advanced diploma in, for example, let's say in applied engineering, as power system or power industry, and so on. So I encourage you guys to really have a good look on the EIT website and understand the different courses and professional certificates that we offer in electrical engineering. Of course, we have a lot of also practical mm, uh, equipments and practical systems to help you not only get familiar with the theory of the system, the but also you have an hands-on experience on some specific parts of electrical engineering. So for example, here just as an example, we have a system like for power transmission and distribution, in which we can simulate, not only simulate, I mean in a small scales we can build and really see different parts of transmission system and so on. We have an inverter to drive some motors, which is a system that is gonna be being used. An inverter and motor is or a drive system is used in almost all cars. I mean, electric cars, in your fridge, in a washing machine, everywhere. So we have a system to simulate that, and that you can have a hands-on experience on that. On the simulation software, I can say EIT has one of the best, universities that is in providing this really practical simulation software. For example, the DigiSilent Power Factory is a software, very expensive software that is only or mainly used in companies or that are doing the consultancy for power system and designing of the power system. You cannot find Power Factory, for example, software not in most of the other universities. You do not have access to this. But here we have something called as remote labs, and then you can connect while remotely to those labs and use these software tools. For example, we have the Homer Pro, again, software tool. We have PSCAD, PSVoice, and so on. But again, I really want to emphasize on the Power Factory, which is a very expensive and very advanced software tool for modeling of big power systems. So by that, since you are going to study and understand all different aspects, you are going to have a lot of job opportunities, especially as I mentioned, by getting more and more going to more and more towards electrical systems. You can think of electrical cars, chargers, all the appliances that we have. So some of the job opportunities you can think of, for example, in the planning and design of the power system, in the companies for power supply, distribution, and transmission, in the renewable energy sector. It You could go to also a lot of minings. I mean, I can tell you, I mean, if you guys are not aware, one of the things that you can see is these big mines that they have these big trucks. You could see, for example, the photos that there is a big truck and there is a small person standing beside that. So for different reasons, these big trucks are getting uh, converted to electric-based trucks. And now you can see that we have such a big system, such a big truck that is going to work just based on electricity, right? And it needs a charging station, right? And this is one of the real things that is happening now. I mean, I'm aware that, for example, we are in companies who are making the chargers. There are a lot of requests that are coming. We would like to have, let's say, 1 megawatt charger station, right? For example, what you the charging station that you, for example, charge an electric car, it might be just 5 kilowatt. But now we can think of a 1 megawatt charging station to charge a big truck that is used in a mine system. So, but coming back to this part is that having the certificate or a degree in electrical engineering is gonna be helpful for you to and open a lot of opportunities in mining sector, especially that they are going towards a more electric based system. And another thing is, for example, in Australia, I tell you as another a new trend and a law that is happening is that if you any mine site which is getting opened or anywhere before, let's say conventional, they were just bringing or making a transmission line to that site. But nowadays, any mine site that is going to be opened and going to be started, before starting the mine, they need to have a renewable systems and a microgrid installed so that that microgrid and renewable system can supply the loads for that mine, right? So you can see now the trend that we have towards the renewable system and the trend that we have towards the electric based system, it's gonna open a lot of job opportunities for you. And then it goes to the space defense that I didn't really talk much about it. Again, making more or faster systems in defense and so on is happening just based on more advanced electrical systems. Yeah, so EIT offers a range of electrical engineering programs for professional development through a formal qualifications. And yeah, so there are, of course, we have a lot of graduates from different parts of the world, and yeah, so yeah, that's all from my side. If there is any question, please shoot. And Lisa, if you can guide me, do we need to you need to go through this slide before I answer the questions, or how do we?
Let me just go over the slides quickly if you're okay with it.
Yes, please. You can continue the slides from here.
Okay, just very quickly. So guys, you may use this QR code and this link here to enter the prize draw for this particular session, because every session of our virtual open event, they actually have like a link for your prize draw. And please note that we won't be giving any certificates for this, because this is not a technical webinar. If you would like to have certificates, you can visit our website events page to see our upcoming technical webinars, and you can join them for free. So let me just go ahead and post this prize draw link to our chat box so that everyone can access the link as well. And yep, we can go back to the QR code later on. Let me just let Dr. Hussein answer all your questions related to this topic. Thank you.
No worries. Thank you very much, Lisa. So I'm gonna go through some of the questions. If I miss some, please let me know. I think yeah, the question that if one completes MIA then wants to do MEE, you have already answered that question. Do any EIT course cover fault currents and study of transients? Yes. In if I go back to this slide, we have this course called MEE. Yeah, sorry, yeah, we didn't include it here. Yeah, we have the course called System Stability Analysis. That this course analyzes the stability of the power system under the faults and so on. We have another course, yeah, power system stability analysis also, which really looks at the systems and the challenges that we have in the power systems with high penetration of renewables, and the challenges that we get in transient performance of these new systems. So we have two courses in the ME, and in the Bachelor of Electrical Engineering also we cover in one of the courses as basics of power system stability. So we covered these two. Mm, so between a power system masters and renewable energy masters, which is more applicable and has more opportunities in the field. I guess both. I mean, even though we are talking nowadays more and more about renewable systems, again, based on the case by case and the country that you are looking for to work in, or even the city that you are looking for, it may each of them may have different or higher chances, but as a whole, both of them really cover almost a similar thing, but one of them, as a renewable system, you also study a little more on, let's say, for example, chemical aspects of renewable systems or mechanical aspects of renewable systems. So in renewable system courses, you really go a little beyond electrical, and you also study those areas also. So the other question, when are you all going to offer aerospace engineering? I don't, Lisa, do you have any answer for that? Uh, yeah, I'm not sure of that question answering. Follow-up question, I am referring to a specific case of MIA as they stand now. Yeah, I think regarding the exceptions about the MEE and MIA, as Lisa mentioned, it is really case by case. But to give you an overall understanding that there are similar courses, there are few of the courses that are similar between the two masters. So I guess if you are having the one of the masters, some of the courses that you have already passed, you could be exempted in the other one. So but as Lisa mentioned, it's really studied based on the case by case. So we cannot have a general answer to that. Uh, I mean, the other question is, do you have good supervisors for masters and PhDs? It's like you go to a supermarket and ask the salesperson, and for example, do you have a good Yugo heart? And he will always say yes, purchase from me. But so the answer to this question, of course, is yes. But just saying, in addition to just a simple yes, I would like to add that a lot of, or I can say, in electrical engineering and other courses that we offer as EIT, a lot of our lecturers and supervisors are coming from industry. So to give you as an idea, in electrical engineering, we are only two full-time staff or lecturers who are working in the just as a company, just as the university, and the rest of the lecturers and the supervisors that we have, they are casual lecturers that they come from industry. So I can really say that this is something that I always say, instead of just simply giving an answer to your question, a simple yes answer to your question, is that I really want to emphasize that having lecturers and supervisors that are working at the moment and simultaneously in an industry makes a big difference, because the examples that they discuss, the works, the problems that they solve, they are based on their industry based experience. So this is something that really differentiates EIT from a university whose um, most of the lecturers are just academics, right? So they may not be really aware of the real and current trends in the industry. But here, our our lecturers as well as the supervisors are really from the industry, and this makes a big differentiation and big difference. Um, so the other question: any courses in electronics, telecommunication, and engineering management? We don't have any specific at the moment course in any of these at the moment, unless if I'm missing any of the professional certificates that Lisa could help me. But yeah, our master or bachelor degrees are just based on the electrical engineering. We do, I mean, of course, in as part of the electrical engineering bachelor or master, we have units in electronics, telecommunication, and engineering management, but we do not have a course that, let's say, specifically targets these two units. The next question: I'm a computer system engineer. Which course will suit me in the electrical engineering field? Please provide information for me to consider. Again, this your question is very specific. I recommend you to contact one of our course advisors, and they are going to be help you to help you, because to answer to this question, you need to know what's your really aim of studying the electrical engineering, and what courses do we have, and so on. So I really recommend you to contact some of the course advisor that we have. I think, Lisa, if you can provide an email or something, it would be great about that.
All right. Thank you so much, Dr. Hussein, for answering these questions religiously for the students. And I'm sure that these information that you have shared are very valuable for everyone in here. And you have gone through the slides as well. Thank you so much. Let us just go ahead and wrap this up. For now. So, for those who would like to know more about EIT, please go to our website www.eit.edu.au. And for those who are in Australia or in Western Australia and you'd like to visit our office, we are at 1031 Wellington Street in West Perth. We also have phone numbers in here that you can take note of. This is for inside Australia and outside Australia. We also have a number for that. And for those questions that are not yet answered in this session, I'm so sorry. As much as we would love to answer them all right now, but we are kind of reaching our limit, our time limit. So please send an email to webinars@eit.edu.au, and we would be more than happy to answer your questions in there or channel you to the right person, even to Dr. Hussein, if it's related to this particular topic. All right. And for those who'd like to know more about our upcoming courses, please go to www.eit.edu.au/schedule, and you should be able to see all of the available courses with our upcoming intake dates. So I will just try to answer some of the questions in here.
Yeah, I think I just, if you let me just answer two of the simple questions. The question that I
Okay.
have noticed about that EIT's Master of Engineering is fully accredited until 2024. The answer: yes, we are in the process of reaccreditation of this course, so it will be continued, and it will remain as accredited. The other question, which is simple again answer: EIT is in which country? I think the base is in Australia, but we have offices in UK and South Africa and different places in uh, different other cities. But yeah, the online courses, it doesn't need you to be in any specific country or city. The last question is simple: do we have a campus master program? Yes. Yeah, we also offer that. Yeah, I'm done. Thank you very much, Lisa.
All right. And again, let me just go ahead and post the questions here in the chat box because we need to wrap this session up. So again, please send an email to webinars@eit.edu.au for those who have more questions and for those who would like to discuss about your eligibility for the course, which particular course would best suit you depending on your career goals or the study path that you're planning to have. Um, Please go ahead and book a call with a course advisor. That is the best way to answer your questions. And I know someone here asked about how to become a professional engineer. Please book a call with a course advisor too, because it really depends on the situation, depending on which state or which country you'll be using that. Is it Australia? Is it your country? There are a lot of things to discuss in that particular matter. So again, we highly encourage you to book a call with a course advisor. And by the way, I am one of the course advisors at EIT, and there are plenty of us who would be more than happy to help you. So who knows, you'll be speaking with me again. So, yep. Just go ahead and book the call if you would like to have like a thorough discussion of the course that you want and the details and the eligibility information. All right. So I'm so sorry, guys. You are very interactive, and we highly appreciate the way you participate in our event today. A really great session. Thank you also, Dr. Hussein, for all those information you've shared. Really compelling one. And yep, I'm so sorry that I need to end this now. So thank you so much. I hope that you booked the call with a course advisor or you would send an email to the webinar's email address. We hope to keep interacting and communicating with you guys. And we also have this event continuing up until Thursday. We have other topics for tomorrow and Thursday. Just go ahead and visit the link that you received in the email for you to be able to still join them. Again, thank you so much. Have a great evening, or have a good night, or have a great morning to those who just started their day. Thank you so much, everyone.
Thank you very much, Lisa, and thank you very much, everyone, and have a good time. Thanks.
Thank you. We will leave the session now.